What about others? Can you hear me?
Yes, Vijay. Yeah.
Okay. Yeah, fine. Let me start the session. So in today's session, we are going to focus on like how to construct a table screen element. But today it will be theoretical, and we'll try to discuss MVC architecture, model view controller. So in today's session, it will be theoretical. So today the entire session will be more or less theoretical. From the next session onwards, we are going to implement these things practically. Table screen element. So this table screen element is part of two different libraries. Table screen element is available as part of two libraries here, according to SAP. So one is SAP.M library, and the second library is SAP.UI.table. So table class is part of SAP.M, and table class is also available in SAP UI table library. So SAP.M library, this is mainly recommended for SAP Fiori applications. And SAP UI table library, this is recommended for UI5 applications, mainly like desktop-based applications. Only in case of desktop-based apps, you can go for UI5. In UI5, generally we use SAP UI table library. But if you want to use an application on all devices, then we go for Fiori. And Fiori supports all types of devices. In that Fiori, we have to use SAP.M library. So as of Fiori is concerned, we'll be discussing this library. In the coming days, when we go for UI5 development, we will try to use SAP UI table library also. So by the end of the course, you'll understand both the libraries. And not only that, table screen element is considered as a complex screen element here, because table screen element internally uses other screen elements. In table columns, table screen element is simply considered as complex screen element just because table screen element internally uses other screen elements here as part of table columns. So one screen element can use other screen element. So table is a screen element which internally uses other screen elements inside different table columns. So we can call it as a complex screen element here. It's not complex in terms of programming, it's complex in terms of terminology. Table coding is very simple, there is no doubt in that. But it is considered as complex screen element just because we use other screen element inside table columns. And not only that, so table can make use of table with table column, and table column can make use of, for example, text screen element. So table can have a column, and that column can be with text property or text screen element. And if you're using text screen element, text is a property we have to use. Table can have a column with a text screen element here with text property. And not only that, table can use a table column with input screen element here. And input screen element will use value property. Similarly, a table can use a column with text area screen element. Text area can be used with value property here. Similarly, table can use a table column with, for example, image. And image will make use of SRC property here. For every internal screen element, there will be some property that has to be used. Okay, similarly, table with column. A column can have rating indicator. Table can have a column with rating indicator as a screen element, which internally uses value property here. Similarly, table with a table column, it can use slider screen element. Slider also uses value property here. And similarly, table column can make use of something like checkbox screen element. And checkbox will use selected property here. Table can have a column with switch screen element. That's another screen element. Switch screen element, and switch screen element will make use of state property here. And not only that, table can use a column with button screen element. Button also can be used as a screen element inside the table with text property. And table can use a column with link as a screen element with text and href property. And if required, we can use a table with column, and that column can make use of progress indicator. That's another screen element. And progress indicator can make use of percent value property. That's an important property. And table can make use of column with date picker. Date picker, that's another screen element for date. And it can use value property here. Similarly, table can make use of column with time picker. And it also can use value property here. And table can use a column as select screen element, which is technically a drop down. And it can use text property. So under a table, we can have a column. Each column can have screen element, and each screen element will have its property. table will use column with a screen element, and screen element contains its own property. So when you construct a table, we can use all these different screen elements with the different properties inside different columns. Okay, so let me give this diagram. If you're constructing a table, then you need to follow this diagram. So what we can do is we can use a table, and table contains items as aggregation property here. For that, we need to maintain relationship with entity set of OData service. So we are going to use table, and table contains items as aggregation property. And you can configure entity set so that you can collect data from backend and display data in the front-end table. So entity set collects data from backend and display data in the front end. So you're already aware of this now. For table also, the same concept is applicable. Entity set can be used to collect data from backend and display data in the front end. Now, in order to construct a table, this is a strategy we are going to follow. So under table, we are going to add a column, and each column contains a label. Each column contains a label. Or else, let me make it simple. Column and column with label. Let us make it like this. So you can have n number of columns, and each column should have some label. Let me just adjust like this. So the first thing that we need to focus is, while constructing table, for each column, you should use a label, something like this. Okay, this is how it looks like. And after column with label, we need to add the screen element. The screen element in this case can be something like a text screen element here. Or a screen element can be input screen element. Or a screen element can be text area. We can use image as screen element. We can use checkbox as a screen element. And we can use slider as a screen element, and rating indicator as a screen element. Rating indicator. So we can use that as a screen element. And not only that, we can make use of something like switch as a screen element, and progress indicator as a screen element. That's one of the screen element we are going to use inside table, progress indicator. And then we can also use a button as a screen element. And like that, we can use something like link as an internal screen element. Similarly, we can make use of date picker. Date picker is one of the screen element we can use. Okay, so let me adjust like this. So we can have something like time picker also as one of the internal screen element inside the table column. And then we can have something like a drop down that is a select screen element. So in different columns, we can have different screen elements. That's a basic point that you need to understand here. It can be checkbox, switch, rating, slider, progress, image, button, link, etc., etc. So this is how it looks like. Okay, let me just highlight this. We can remove this now. Right, so now if you are using a text screen element, then we have to use its property. For example, if you are using text screen element, then we have to use text property here. If you are using input screen element, we have to use value as a property. For text area, we use value as a property. For image, we use SRC as a property. Checkbox selected is a property. For slider, we use value as a property. Rating indicator also will use value property. And switch screen element will use state as a property. Progress indicator will make use of percent value property. It will make use of percent value property. And button will make use of text property. Link can use text or href property. And date picker, value is a property. Time picker, value property. Drop down select screen element can use text property. So this is how we are going to follow. Every screen element has a property, and that you can use it in different columns for data binding. Okay, let me just complete this. This is useful when we write the code. So not only that, as a developer, what we need to do is for every screen element property, so for each screen element property, what we need to do is we need to establish data binding relationship with OData field. As a developer, we need to establish data binding relationship with OData field here. So OData field 1, field 2, field 3, etc. You can use it. This is like OData field, so that has to be used in data binding. For every screen element property, we can use OData field in data binding. So while writing the code, this is how you need to follow the pattern, especially for table. So that means for screen element property, we establish data binding relationship with OData fields here. Whichever fields you want, you can use it and maintain data binding with OData fields in this manner. Every screen element has a property. For that property, you can establish data binding relationship with OData field. So that means after maintaining data binding relationship, what you can expect is you can expect collection of records for those different columns. So finally, you can expect collection of records, record 1, 2, 3, etc. Okay, something like this. So we are establishing a relationship with entity set. Entity set may get 100 records. All 100 records will be displayed inside the table. For so-and-so columns with which we maintain data binding relationship with OData fields. So this is the approach, but while writing the code, you need to remember one basic point. First, main screen element here. Table is a main screen element. So table is a main screen element. You need to use that. And not only that, I can say we have to use a column with a label. And column label, and each column should have some screen element that we call it as internal screen element here. Internal screen element. And internal screen element contains a property here. So property has to be used. And for each screen element property, we need to establish data binding relationship with OData field. So we need to establish data binding relationship with OData field in this case. So first main screen element, then that screen element can have a column with column label, and then we can have screen element for each column, the property for each screen element, and data binding relationship with OData field, whichever you want to use. So these are some of the things that you need to consider while constructing a table. It can be a standard application or a custom application, and not only that, it can be any OData service. Ultimately, this pattern remains same. And you may use any tool, Business Application Studio or Web ID tool, but this entire procedure is not going to change. It remains same. Irrespective of the service, the screen element in the front end remains same. So the point here is table is the main screen element here with items as aggregation property. For items, what we do is, for items, we configure entity set of OData service. And table can have internal screen element with its property for data binding relationship with OData field. So these are some of the things that you need to consider. And please remember the most important note. So the table screen element is same and applicable for all types of OData services. And table screen element is same and applicable for all types of tools. So it can be SAP Business Application Studio or it can be SAP Web ID. It doesn't matter. The coding in the front end is not going to change. And whether you consume OData ABAP service or HANA service, HANA-based CDS service, or it can be OData Excel service. It doesn't matter. The table screen element behavior, coding, procedure, everything remains same. So just remember these two important points. It is applicable for all types of services and it is applicable for all types of tools. There won't be any single line change. At some point of time, I'll show the same table screen element on Business Application Studio also. No need to worry. Okay, let me save this. Now, practical part of the table we'll discuss in the next session. Don't worry. Now let me focus on the next point here. That is MVC architecture. Let us understand what exactly it is, how it is useful for us. So MVC architecture, MVC stands for Model View Controller. And in our application, what is model, what is view, and what is controller? Let us understand that in detail. And then we'll try to understand the advantage of MVC architecture. So let us understand what is model, view, and controller, and what type of things we are going to utilize inside these three options. Let me take one separate diagram here. So there can be something like SAP ECC as a backend, or it can be SAP CRM as a backend, or SAP SRM as a backend. So for this type of backend systems, what we can do is we can make use of something like OData ABAP services. And inside OData ABAP services, we can implement database functionalities. We can implement database operations. So it can be ECC backend or CRM backend or SRM. For this type of backend systems, what we can do is we can develop OData ABAP services and we can interact with these things to deal with database operations. So any service which deals with a database functionality, we technically call it as a model. any service which deals with a database functionality, we simply call it as a model or business logic here. It can be a class or a service or a RFC, anything which deals with a specific database functionality, that we generally call it as a model, or you can call it as business logic here. And similarly, there can be SAP S4 HANA backend. The backend can be SAP S4 HANA backend. So for this type of backend systems, we can use OData ABAP services or CDS-based services. It all depends. But any service generally contains a database operation here. So technically, OData HANA CDS-based service, you can use it for interacting with SAP S4 HANA backend. It also contains database operations, but any service which deals with a database functionality, we call it as model or business logic here. And not only that, there can be a non-SAP backend here. There can be a non-SAP backend. For non-SAP backend, we generally make use of something like OData external services. And OData external services also contains database operations here. And okay, let me just complete this. OData external service deals with non-SAP backend here for database operations. And any service, whether it is external service or CDS-based service or HANA-based direct service, ultimately it deals with a database functionality. We call it as a model or business logic here. So the point here is, according to our UI5 Fiori applications, a model can be OData ABAP service, model can be OData HANA service, or a model can be OData external service. So any service which deals with database functionality, we call it as a model according to MVC. So the point here is, model represents database functionalities. Model can be OData ABAP service, or model can be OData HANA CDS service, or a model can be OData external service. All these services deals with database functionality. So any service which deals with database functionality, we call it as a model. Or you can call it as business logic. Okay, not only that, let me complete this diagram. So here there can be screens with screen elements. We are going to create screens with screen elements in our Fiori or UI5 applications. Screens with screen elements, for example, it can be table, list, charts, microcharts, forms, etc. Any screen element. So screens with screen elements that type of code, we are going to write it in UI5 as well as in Fiori at view level. So screens with screen elements, the code related to screens and screen elements like table, chart, list, etc. So that type of code we have to implement as part of a view here. We can call it as a presentation logic here. View is technically part of presentation logic, which is nothing but a screen with screen elements in simple words. So it can be in UI5 or it can be in Fiori. View is nothing but a screen which contains the code related to screen elements. And we can also call this as presentation logic here. So view represents screens with screen elements. View represents screens with screen elements like, okay, we can also call this as presentation logic here. Let me highlight this. Presentation logic. So in UI5, you will find views. In Fiori also, you'll find views, but ultimately it contains the code related to screens and screen elements. That should be part of a view. And not only that, as a developer, what we can do is we can make use of something like a controller. Controller can instantiate OData service. From controller, we can instantiate OData service. And from controller, we can consume OData service. And from controller, what we can do is we can transfer data between model and a view. We can transfer data between model and view. That should be implemented as part of controller. And we can share the data with multiple views. We can share data with multiple views. So that type of functionality also can be implemented in controller. And not only that, we can handle navigation. We can handle something like routing technique for navigation purpose. If you want to jump from one screen to another screen, we have to apply routing. That means we need to apply navigation, and that navigation we can handle through controller. And not only that, the most important is under controller, we try to handle event handlers with functionalities. We can have n number of event handlers. Each event handler can have its own functionality. So that is also part of controller. And not only that, we can handle front-end validations. Screen-related validations or field-related validations. So all front-end validations we can handle at controller level. And not only that, we can handle dynamic changes. Dynamic changes on screens or screen elements. Dynamic changes on screens or screen elements. So all these type of things we can handle as part of controller. Not only that, anything other than screens and database functionality. Anything other than screens and database functionality. So all those things we can implement as part of controller. So here we can have a controller, and this acts like a mediator. It acts like a mediator between a model and a view. So controller can act like a mediator between model as well as a view. Between any model and any view. So the data flow can be like this. Or data flow can be model to view. So from view to model and model to view, that is applied through controller. We can do this. So data flow is bidirectional. Data flow is bidirectional between models and views, and that data flow we can control through controller here by consuming or accessing OData service. So if you closely observe this, okay, let me write it here. So as I told you, controller acts like a mediator between model and view. Controller can handle consumption of OData service. Controller can handle consumption of OData service, or controller can handle instantiation of OData service. Controller can initialize the values. Controller can be used to initialize the values for screens or screen elements. Controller can handle event handlers, the most important event handlers with functionalities. Controller can handle front-end validations or screen-related validations or screen field-related validations. So that we can handle in controller. And controller can handle data transfer between model and a view. And controller can handle data transfer or data sharing with multiple views. Controller can handle data sharing with multiple views of that same application. And not only that, controller can handle dynamic changes on screens or screen elements. So those type of things we can implement as part of controller. And not only that, controller can handle navigation using routing technique. We have to write some piece of code in controller for applying navigation using routing technique. So all these things we can implement as part of controller. In the different sessions, we are going to use different techniques. Don't worry. In some of the sessions, we'll handle validations. In some sessions, we handle event handlers, dynamic changes. So everything will come at right time, no need to worry. So everything other than screens and screen elements and database functionalities, the remaining functionalities we are going to implement inside controller. So database functionalities is part of OData service. Screens will be part of views. And other than those two things, the remaining functionalities has to be implemented inside controller. So not only that, I can say, so according to this diagram, so here view and controller will be part of the front end. View and controller technically is part of the front end application. So controller is part of front end, and the front end app can be UI5 app, or it can be SAP Fiori app, or it can be a .NET PHP application also. So the front-end apps contains views and controllers. It can be UI5 app or a Fiori app, .NET PHP app. But ultimately, generally it contains controllers as well as views in the front end. And these OData services, we call them as backend services in general. These OData services, we can call them as backend services. The backend service can be OData ABAP service, as I told you, OData HANA service, or it can be external service. But these are technically backend services in general. So backend services acts like models here. And the front-end application contains views with screen elements and controllers with various other functionalities. So technically, what is happening by following MVC? If you follow MVC architecture, the business logic is separated from presentation logic here. When you follow MVC indirectly separates business logic and presentation logic here. So when you separate business logic from presentation logic, I can say the models becomes reusable. Models can be reused in UI5 apps, models can be reused in Fiori apps or .NET PHP apps. So the point here is so SAP UI5 apps, Fiori apps follows MVC architecture. As per MVC architecture, presentation logic and business logic are separated. Presentation logic and business logic, they are separated according to MVC architecture. So we can reuse, we can achieve reusability here. That's the main advantage. We can achieve reusability. So how can we achieve reusability here? When you separate presentation logic from business logic, according to MVC, it says that we can have reusability feature. So that is, OData services can be reused, can be accessed or reused in various front-end applications like UI5 apps, Fiori apps, or even .NET PHP apps. So that is one of the simple advantage by following MVC architecture. We can achieve reusability, especially OData services becomes independent services. OData services becomes reusable services. So different front-end apps can access those services whenever, wherever required. So these are some of the theoretical points you need to notice here. Now you can see here, let me go back to this. Okay, let me just write it here, MVC architecture. This diagram is very important. Should be on your fingertips. So what type of things will be part of screens? What type of things will be part of controller? And what will be part of models? So you should have clarity on these three different options. Okay, now you can see here. So if you closely observe a table can have several screen elements, and table can be a simple screen element. Let me show that here. Anyhow, we are going to start that from next session, but let me just highlight this one. So here you can see okay, you can see here, there is a table screen element here. And this is a table screen element, but we are not using different internal screen element. We are using only one screen element here internally. So we can have a table like this. But in this table, every screen element has a column with a label, but every screen element is using a text screen element. So column 1, column 2, column 3, column 4, etc. So all these columns are using the same screen element here. So columns can use same screen element in a table. That is possible. Not only that, that is one way of developing the app. That is a simple table. But not only that, let me show it here. Here you can see there is another table. This table uses various other screen elements in this case. So now you can see there is a table output here. And in this table, if you closely observe, we are using different screen elements in different columns. So this is also a table, and there are different columns here. And inside this, you can see we can enable a checkbox or a radio button. We can enable checkbox or radio button for selecting the record. And inside a table, we can have a button. You can see this. Inside a table, we can have a text screen element. We can have a link. And we can have object number. That's another screen element. And inside table, we can have images or icons. A table can have a column with checkbox. A table can have column with switch, rating indicator, and progress indicator, then slider, etc. So a table can be a complex screen element when we add different screen elements as internal screen elements here. So in this case, a table contains columns with different screen elements. And we can apply conditions. We can attach formatter functions. We can make the table more and more dynamic. We can provide table with more user interactivity features. by providing different screen elements in different columns inside the table. So we can have a background image for a table. All those things can be applicable. So the point here is, let me highlight one simple note. Okay, let me highlight here. Table can have different columns with same screen element. That is possible. Or table can have different columns with different screen elements. This is also possible. So both we are going to understand from the next session. But these are the two simple points you need to notice. Table with different columns using same screen elements, different columns using different screen elements. Both techniques are possible. I'm just introducing the basics before we write the original code. And not only that, here you can see every project contains a formatter file here. You can see there is a model. There is a formatter file here. Under formatter file, what we do is we apply some different conditions. So please remember, from the next session, we are going to use formatter file also. Formatter.js file is a separate file and it's a global file for that entire project, and it can have a formatter function. Function 1, function 2, function 3. So we can implement formatter functions here so that we can apply different conditions. So different columns can have different formatter functions. We can apply different conditions. We can return value based on the conditions. So that we are going to do it through formatter.js file here. Whenever you create a project, by default, you'll get this formatter.js file. It is mainly for implementing formatter functions. Okay, let me write a simple note. Table can be created without formatter functions. Without formatter functions. And table can be created with formatter functions. One is without, another is with. So when you create a table, table can have a formatter function. Table can be created without formatter function. So there are two ways of creating a table. So both techniques we are going to understand, but formatter functions has to be implemented. In case if you are using formatter function, it has to be implemented inside a formatter.js file. We are going to use that. So don't worry now. Let me introduce some basics about formatter functions here. So in which situation we have to use formatter function? So formatter function is used to return a value based on condition. We can use formatter function in order to return a value based on some condition. If else condition, switch case, whatever. So when you want to return a value, something based on condition, then formatter function is used. Not only that, formatter function is used to return a calculated value. You have a value, but I want to have some calculation. After that, I want to return the final result. So we can return a calculated value. That is also possible through formatter function. adding two values or subtracting or some other calculation. So after applying calculation, you can return the final result through formatter function. That is possible. And formatter functions must be implemented under a formatter.js file. Formatter functions must be implemented as part of formatter.js file. That is a separate file designed to implement formatter functions. All the formatter functions of that application should be available inside this file only. And please remember, formatter function is executed automatically executed automatically for each and every record in an entity set. So formatter function is executed automatically for each and every record in the front end based on the number of records available in an entity set. If entity set which you are using for table, if entity set is having 10 records, 10 times the formatter function is executed automatically. If entity set contains 100 records, 100 times the formatter function is executed. So that's a basic behavior of a formatter function. So formatter function is getting executed automatically for each and every record available in an entity set. If it contains 50 records, so 50 times the formatter function gets executed. And most important point, let me highlight here. Formatter function is or can be applicable, or it can be applied on any screen element. Formatter function is a general concept. You can apply on table, list, chart, microchart, or any other screen element here. So formatter function concept is a general concept. You can apply on any screen element, like it can be on table sometimes, it can be on list, or it can be inside the form, or it can be on a chart or a microchart, etc. Because it's a general concept, you can apply on any screen element like this: table, list, form, chart, microchart, etc. So these are some of the points you need to notice in terms of formatter functions. We are going to implement this practically, no need to worry. So I'll stop here. If you have any doubts, you can ask me. Any doubts from your side? Previous sessions or today's session? Any doubts? Hello students, can you hear me? Can you see my screen?
Devika here, like in WebDAM Pro, we have view controller, custom controller, like global controller, anything like here.
There is no such controller, but technically there will be a manifest file, manifest.json file. So this is technically a global file. And there is a formatter.js file. So there will be global files for dealing with common functionalities of that entire application. So this is also a global file. And each view contains a controller. Each view is associated with a controller. So this is how we are going to deal with. But in WebDAM Pro applications, we have a component controller that is technically a global controller for that application. And there will be a view controller that is technically a local controller to a view, related to a view. So, but in UI5 Fiori applications, we are going to have some views, but every view contains a controller that is local to a view. But manifest.json file, formatted.json file, so these things can be used in the form of a global options or global files or a global controller. Okay, so that's a basic difference. Okay, then next doubt. Vasant, Supriya, Sunil. Any
Vijay,
doubt?
Lohit here.
Yeah, Lohit, what's the doubt?
This formatter file which is there, it belongs to the controller or to the model?
It is not exactly frankly speaking, it is not a model, but it's a global file. That's the reason why they kept it as part of a model folder. That folder name can be anything, it doesn't matter. But
Okay,
the file which is related to formatter function is a formatted.js file. That's a global file. Okay.
Okay, so that folder doesn't matter, right?
Yeah, that folder can be XYZ. Yeah.
Okay.
Then next doubt. Akash, Anand Singh, Ashwin.
Hello,
Any doubts?
good morning, Vijay.
Yeah, Anand Singh, what's your doubt?
Vijay, formatter function runs as many times as the number of records in the entity set. So will that not be hampering the performance of the application?
Of course, there will be some performance. It's not exactly, you should not consider that as a performance problem. Okay, if you consider each concept as a performance issue, then there is no point in developing the application. So sometimes we have to compromise just because if you want to execute a condition for every record, then there is no alternative. We have to go with formatter function itself. It is just one single line. The one single line code gets executed each time just before displaying the record. But please remember, the formatter functions are executed in the front end, not in the backend server. It is executed in the front end. So there is no point in talking about performance here. So all formatter functions are executed in the front end. They're executed in the front end app within the browser itself, not in the server. So
if the condition has put for every record, only then it will run for every record, right?
If you attach a formatter function for a screen element, we can attach a formatter function. When you attach a formatter function, then that gets executed every time for every record. But the execution happens always in the front end. So there is no problem with the performance because the formatter function is not executed in the server. Okay. So formatter function is attached to a screen element in front end. So if you attach a formatter function, then only it gets executed. If you don't attach, then there is no point in executing that. So attaching formatter function or not attaching formatter function is up to your requirement. Okay. Yeah. Then next doubt.
Hey Vijay, this is Mahendra. Can you hear me?
Yeah, Mahendra, what's the doubt?
So if we have the screen element, and the table has a screen element of 10 fields, and we have a 5 formatter functions. Okay. So is that going to trigger 5 times for each record?
The formatter function is assigned to a screen element of a specific column.
Correct.
So screen element of a specific column. So if column 1, column 2, column 3 are having 3 formatter functions, right? So for every column, for every record, those formatter functions gets executed. Yes.
It's element level, correct?
Yes. Yes.
Okay. So are we going to call these formatter functions in the view, or are we going to call from the controller?
Formatter function is attached to screen element. So can you tell me where the screen element will be available? Screen element will be available at view level.
Okay.
Okay. But the execution of formatter happens with the help of controller. Okay. The condition
Okay. The
executes with
functions
the
are
help
going
of
to
controller.
execute in.
Yeah. I think your voice is breaking, Mahendra. I hope I have answered your question. Don't worry. If you want more clarity, you just need to wait for another 48 hours so that we can come across all these topics practically.
Sure, Vijay. Thank
Then,
you.
yeah, next doubt.
Vijay, like in
Hi,
WebDM Pro, do
Vijay.
you have any hook methods here?
Here also we have hooker methods that we'll discuss later. Don't worry about that now. So those are all coming days topics. So there will be hooker methods. So there will be on init, on before rendering. In Fiori, these things are very rarely used. On init is very commonly used, but on before rendering, on after rendering, these are very rarely used. On exit. So these are the hooker methods. So hooker methods will be common for all types of applications in general. On init, on before rendering, on after rendering, on exit. By default, if you don't write any code, then those methods will never come into picture at all. Only if you write the code, then only those methods gets executed. But how they are executed, what's the sequence, I'll be explaining in one of the example. So technically on init is like your initialization in your WebDin Pro. So on exit is also like exit method in your WebDin Pro. And before rendering, on before rendering is like before loading the screen, something like there is POA, POB, something like those type of methods will be available. I could not remember those appropriate methods, but in UI5 apps also there will be hooker methods. These are nothing but hooker methods. SAP UI5 Fiori apps contains hooker methods. These are technically lifecycle methods. But these methods plays an important role when you are developing stateful applications. In stateless applications, these things are really not so important. But still, we are going to use some of these methods. Sometimes on init, sometimes on exit, before rendering. We'll try to use some of these methods. But technically, they are hooker methods. These are common for UI5 apps, Fiori apps, as well as WebDim Pro applications. So hooker methods are nothing but lifecycle methods of a controller. Yeah, next doubt.
Unmuted.
Yeah, Sunil Singh, what's your doubt?
Sir, in coming session, are we going to learn about the notification, like?
Notification message.
Yes, sir. Notification like used to come in Fiori. That things.
Notification service or notification message?
Notification message.
That we can discuss when we go for messages. You will have different types of messages: message box, a message toast, and other notification messages. Yes, we can display.
Okay.
Just try to remind me. When we go for message concept. There is a concept like handling messages in Fiori. At that level, we'll discuss that.
Okay, sir.
Yeah. Then Vasant, Srinivas, Shahida, Shakir, Sainath, any doubts? If anyone is having doubt, you can unmute and you can speak. Mohit,